Hello everyone, we want to welcome you once again to this lecture. In this lecture, we're going to discuss the primary types of PLCs. In our earlier video, we discussed what the PLCs are, the hardware components, the advantages, what they are where they are real used in the field outside there. So in this kind of discussion, we are going to look at the primary types of programmable logic controllers. Now, one of them is that we have a fixed type of PLCs, and that is the compact type. This compact type has an integrated design in a way that all components, including the CPU, the power supply, the input-output modules, are housed in one single unit. And of course, this has limited expansion because since it is a compact and everything is contained in one single unit, you find it is difficult for further or future expansion. And this is ideal for small scale applications with fewer input-output requirements. And this can be in simple machinery controls. For example, maybe you have a motor that is maybe in a block or paver making a machine. You can use such kind of a compact design because you have few components and maybe a few motors to control. Therefore, you can use this one. Then we have modular PLCs. Those are the modular programmable logic controllers. This one has a flexible design. There is a high level of scalability, and this is because they have separate modules, one for CPU, power supply, input-output modules, allowing customization and expansion. Then we find that these are typically used in medium to large scale applications such as complex manufacturing processes and industrial automation, like in car manufacturing, steel manufacturing, and so on and so forth. Then you have the rack-mounted PLCs. These have a centralized architecture. They use a rack or a chassis to house various modules, and that is they include the CPU, I/O, or the input-output, the communication protocols or the communication channels, and several other specialty modules. So this one is where we find that the PLCs are mounted on chassis, and they have also high expandability for future and other advanced systems. So the typical usage is also for large industrial applications. We have soft PLCs. These are software based and they run on a standard industrial PC or server instead of dedicated PLC hardware. These are versatile and powerful, and they leverage the processing power of modern PCs and can integrate with other software applications. We find them in advanced computing power and integration with other IT systems. So where you find you need to integrate your system with other IT or information technology systems, you'll find that this kind of PLC that is software based is so much relevant there. Then you have safety PLCs. These are designed specifically to meet stringent safety standards, and the IEC 61508 is one of those standards that talk about safety, and therefore you can use these safety PLCs for this. Of course, you can use them for others, but you'll find, you can use them for other applications, but you can also capitalize on them to work in those safety critical applications like in emergency shutdown systems, safety interlocks, and hazardous environments. You have nano PLCs. These are ultra compact size. So with the introduction of nanotechnology or advancement of nanotechnology, you find even these PLCs, you can have them in very small components. So you find they are smaller than standard compact PLCs and with limited input-output capabilities. They are so cost-effective and they are designed for simple automation systems for small, simple automation projects like lighting control and the small machine control systems. Then you have the distributed control system, integrated PLCs. So you have PLCs with the distributed control systems, and these are hybrid systems that combines features of PLCs and DCS for process automation. Then integration, you find that they offer centralized control with flexibility of distributed components. And you find such kind of systems in chemical plants, refineries, and large-scale manufacturing. Then you have also brick PLCs. These are called the all-in-one units, and you'll find that they are also similar to compact, but typically you'll find they are more integrated with fixed input-output configurations. They have also limited flexibility and they offer almost no expansion capability. You have field-mounted PLCs. These are to be directly mounted in the field close to sensors and actuators. So where you need to have, of course, where you'll find that the housing structures cannot be far away from the field. So you'll find you need to install this or apply the field-mounted PLCs. These have a rugged construction and they are designed to withstand harsh environment conditions like in mining operations where you have a lot of noise, where you have issues with humidity, dust, and so on and so forth. Then you have the micro PLCs. These are smaller form kind of PLCs, and they are designed for applications that require minimal space. So where you have limitations of space, you go by the micro PLCs. They are also ideal in smaller machines, home automation, and simple industrial processes. So in this video, we also want to look at the programming languages for PLCs. So the IEC 61131-3 standard defines the programming languages for programmable logic controllers and is widely supported by many programming environments. The standard specifies about 5 programming languages, and one is the ladder logic, the function block diagram, structured text, instruction list, the sequential function chart, and all of these are applicable depending on how easier it is for you to program the logic, the programmable logic controller with them, and you will be able to run the PLC with any of these programming languages. Unlike for microcontrollers, where you need to learn C, maybe embedded C, C++, or assembly language, you find the ladder logic, for example, is easier to learn and easier to work with than those other complicated programming languages for microcontrollers. Now, ladies and gentlemen, allow us to stop here and see you in another lecture. We are going to be talking about the real practical PLCs in the field. Thank you.